Hello and welcome to a new video lecture. In today's lecture, we are going to preview the requirements to build a successful AI product and push it to the market. We are going to answer the question of what does it take to build such software. In many cases, you start with a great idea based on innovative technology, but then you don't have all the tools at hand to build it into a successful software product. I'll start by introducing the conjoined triangles of artificial intelligence. It is a terminology that I have coined together, inspired by the TV series Silicon Valley when they had the conjoined triangles of success. At the foundation of this diagram is the algorithm design, and that's why you need a professional machine learning engineer or even sometimes a data scientist with at least a PhD. They will come up with the algorithm, the mechanism, the techniques that will solve the actual problem at hand. And in many situations, they will even design a custom objective function, that is, the criteria that the whole model is trying to minimize or maximize. For example, you can build a model that tries to minimize energy consumption in corporate buildings. And for this case, you need to design a special objective function that takes into consideration different factors, such as the number of people inside the building, the working hours, the holidays, and so on. On the side of the triangles, a standing leg, which is the training data. So far you can't take the algorithm and put it in production and introduce it to end users because so far you have not trained it to do anything. And you can't achieve this goal without having abundance of training data. So that's the second thing you need to think about very carefully. Where do I get my training data from? Is it publicly available? Is it protected by an IP? Is it a private data set that I can purchase? There are many sources where you can accumulate this data from. It can be one or the other or a combination of all of them. At the end of the day, you can't have an algorithm without enough training data to train it. And this leads us to the other side of the triangle, the computing machinery or computing power. If you have enough data, you have a great algorithm, and you don't have enough GPUs or TPUs to train this algorithm on. That's why big tech companies such as Google and Amazon, they invest a huge amounts of money in infrastructure, data centers, and so on. And there are many questions to consider when deciding where to get your computing power from. Is it an on-premise data center? Is it going to be a hobbyist GPU rack? Are you going to use a cloud provider? And there are many alternatives in this case, and you need to evaluate the budget versus what you're trying to achieve and take it from there. Now that we have the three sides covered, the algorithm design, the training data, and the computing power, you are ready to fine-tune the hyperparameters. That is, to find the right values for the different configurations of your algorithm. And be aware that these values can be very different from training set to the other. Based on your data, you need to find the right values for this data set at hand. And this process is very time-consuming and very demanding when it comes to computing power. Usually the engineers or the practitioners on your team will spend days, weeks, or even months to fine-tune the performance only to obtain 1 or 2% improvement in accuracy if you have decided to begin with that accuracy is the right metric for your product. And that's a decision that is made by the lead researcher or lead engineer at the first step of this process in the algorithm design step. Usually the 4 steps that I have described so far are incremental in nature and iterative. That is, you start with an alpha product with accuracy 85% and then iterate, improve the accuracy to 90% and so on until you get the satisfaction from the model at hand. Once you have completed the previous 4 steps, you are ready to deploy your model into production and put it in the hands of end users. And this turns to be a whole story on its own. The deployment, you need to decide on the availability, the scalability of your model, the number of users, the time requirements for the model to do its predictions. For example, you can have a great model that solves a very challenging problem, but then it requires a few minutes to do predictions on the new data. And then from a business point of view, is this acceptable or not acceptable? Can your users wait for the results to be processed for a few minutes and then return the results to them? Or do you need a more real-time approach to the process? And that will take you back to the whole algorithm design thing and to start with the question whether you need real-time processing or you need a batch processing, offline processing. And there are many other requirements that need to be satisfied for the deployment. Are your users going to use this new AI functionality on mobile devices, smartwatches, or are they going to use it on embedded systems, smart home devices? There are many alternatives, many things that you can think of. And based on the tier or the level where your model will live for its production time, then you can decide, I need to optimize for storage, I need to optimize for CPU cycles, and the field of AI optimization for the edge, or edge AI in short, is a whole field on its own. So you can see here the deployment is not an easy job, and it requires a dedicated team on its own. Teams for the cloud providers, the infrastructure, the message queues, the storage, the processing in the cloud or in-memory computing. There are more than few moving parts in the cloud and in the edge sides of the process. So to wrap it up, to build a successful AI-based software, you need first an algorithm design, enough training data, computing power, and then you need engineers to fine-tune the hyperparameters of your model to fit your training data. And finally, you need DevOps engineer or cloud specialist who can take it from a prototype stage to deployment for end users to consume on the edge, embedded devices, mobile applications, or even web applications. I hope you found this lecture on the requirements of artificial intelligence software useful, and I hope I answered your question of what does it take to build the software from the idea stage to the production stage. At the end of this lecture, I would like to offer you a coupon code for my courses on Udemy, YouTube-channel. I have published 2 courses, one in the area of generative adversarial networks and the other in the area of IoT or Arduino programming. Thank you and see you in a future lecture.